Now we are taking the third topic, moment of inertia, and in that first question is the moment of inertia of a thin rod about an axis passing through its midpoint and perpendicular to the rod is being given by the value. The length of the 400-gram rod is nearly, and these four options have been given. This question has come in the NEET last year 2024, and this is on the page number 114 of new NCERT. If you remember the table I have given to you about the moment of inertia, there I have drawn the figure also and given you the formula for the same. So it is directly formula based question. We are having a thin rod. This moment of inertia of thin rod is given by ml square by 12, and the moment of inertia of the rod is being given 2400 gram per centimeter square, and the mass is being given 400 gram, and we need to find out the length. Since it is given in the CGS system, so the answer will be coming out in the centimeter, and options are also in centimeter, so there is no need to change the units. So we'll put the values 2400 for moment of inertia, mass is 400, L we don't know, that is what to find out, and 12 is in the formula. So this is 2400 into 12 over 400, L square is equal to this. So this cancels, the 6, it is 72. L square is 72. So L is under root of 72. Under root of 72, it is not perfect square. If we'll solve, the value comes out 8.48. So this is nearly equal to the, if we look at the first option, it is 8.5 centimeter. And if we do the rounding off, the value of 8.48 is nearly equal to 8.5 centimeters. So our calculation goes with the option A, and the answer for the first is option A, 8.5 centimeter. Now the second question is the ratio of radius of gyration of a thin uniform disk about an axis passing through its center and normal to the plane to the radius of gyration of the disk about its diameter is, and these four options have been given. This question has come in the NEET 2022. It is on the page number 115 of the new NCERT. To solve this question, first we see what is the relation between the radius of gyration and the moment of inertia. So we have I is equal to mk square, where I is the moment of inertia, m is the mass, and k is the radius of gyration. From there we get k is equal to I by m under the root. For a thin uniform disk, the radius of gyration we will be calculating for the passing through its center and normal to the plane. For uniform disk about an axis passing through its center and normal to the plane of it is B K1, and I1 is its moment of inertia. Let K2 be the radius of gyration and I2 is the moment of inertia of the disk about its diameter. So we have K1 is equal to I1 upon m, and K2 is equal to I2 upon m. Now, taking the ratio of two of them, we have K1 upon K2 is equal to I1 upon I2. If we are talking about the I1, that is when the uniform disk about an axis passing through its center and normal to the plane of the diameter, the I1 will be given by m r square by 2. And when the disk about its diameter, the I2 is given by mr square by 4. So using the formula for the moment of inertia of the uniform disk, one time it is passing through the center normal to the plane and another time it is about its diameter. So putting these values, we have mr square by 2 into 4 over mr square. So this cancels and we have it is equal to root 2 is to 1. So from here we have K1 is to K2 is equal to root 2 is to 1. And if we look at the option, the result goes with the option number A, and the answer for the second is option A, root 2 is to 1. The third question, the ratio of radii of gyration of a circular disk to that of a circular ring, each of same mass and radius around their respective axes is. And these four options have been given. This question has come in All India PMT 2008. So first we'll write about the relation between the radius of gyration and the mass and the radius. We know the radius of gyration is under root moment of inertia upon the mass. For the radius of gyration of disk, we denote I is the moment of inertia of the disk and m is the mass. And for ring, it is the moment of inertia of a ring to the mass. M will remain the same according to the statement. Mark it as equation 1 and 2. Dividing two of them, we have K disk upon the ring. The radius of gyration of disk to ring is given by the moment of inertia of disk to moment of inertia of the ring. And putting the formula for the moment of inertia of disk, that is m r square by 2, and for the ring it is mr square. Since mass and radius remains the same, so we have mr square by 2 1 by root 2. So the ratio of the radius of gyration of disk to the radius of gyration of the ring is equal to 1 is to root 2. And if we look at the options, it goes with the option number B, and the answer for the third is option B, 1 is to root 2. Question number 4. A circular disc is to be made using iron and aluminium to keep its moment of inertia maximum about a geometrical axis. It should be so prepared that aluminium is at interior and iron surrounds it. Option B, iron is at the interior and aluminium surrounds it. Or C option, aluminium and iron layers are in alternate order. Or the fourth option is sheet of iron is used at both external surfaces and aluminium sheet as inner material. So these are the four options given, and this question has come in All India PMT 2002. This is on the page number 114 of new NCRT. Now to answer this question, we will go to the concepts. We want the moment of inertia to be maximum. So moment of inertia depends on two of the things. The first thing is about the distribution of mass, and and second one is about its axis of rotation. So these two important things are there. Now, if we talk about iron and aluminium, the density of iron is greater than aluminium. It is greater than density of aluminium. So the iron will have maximum moment of inertia if it is far away from the axis. To have maximum moment of inertia, the iron should be at greater distance from axis of rotation. So after taking these concepts, after taking these three important concepts and concluded this thing, that iron should be at the outer side and aluminium should be in the inner size. So if we talk about the first option, iron is at interior and iron surrounds it, it is the correct option, because in this case iron will be at the greater distance from the axis of rotation, and since it is having the greater density, and this is what we want, to have the maximum moment of inertia. So answer for the fourth is option A. Aluminium at the interior and iron surrounds it. Now let us take the topic of kinematics and dynamics of rotational motion. And in that, the first question is the angular speed of a flywheel moving with uniform angular acceleration changes from 1200 rpm rounds per minute to 3120 rpm in 16 seconds. The angular acceleration in radian per second square is, and these four options have been mentioned. This question has come in the NEET 2022. It is on the page number 117 of new NCRT. To solve the question, let us see whatever the things have been given to us. The angular speed of a flywheel moving with uniform acceleration changes from 1200 rpm. So here initial angular velocity omega naught will be given by 2 pi. This is 1200. These are the rpm. So we have to find out the angular acceleration in radian per second square. So we'll change this rpm in rps. So we'll divide by 60. These are the rounds per second now, and the value will be, on solving it, we have 40 pi rps, and omega is given by 2 pi 3120 upon 60 rps, and this value comes out 104 pi rps. Now to find out the angular acceleration, we will apply the formula omega is equal to omega naught plus alpha t, and here time is given to us 16 seconds. So let us put the values. 104 pi is equal to 40 pi plus alpha into 16, and we get, this is the alpha angular acceleration that we are going to calculate. 104 pi minus 40 pi divided by 16, and the value comes out 64 upon 16 pi. So the angular acceleration in radians per second square comes out 4 pi.
and it goes with the option number A, and the answer for the first is A option 4 pi. Now is the question number 2. The instantaneous angular position of a point on a rotating wheel is given by the equation. The torque on the wheel becomes 0 at, and options for the time have been given. This question has come in All India PMT 2011, and this is on the page number 117 of new NCRT. So, if we see the statement of the question, according to that, the torque on the wheel becomes 0. The torque is 0, it means the angular acceleration alpha, that is 0. Now, one more thing is there. The angular acceleration alpha is the second derivative of the position, where theta is the angular position. The value of theta is given to us 2t cube minus 6t square. So first derivative is 6t square minus 12t, and second derivative is 12t minus 12. Mark it as equation number 1, this as equation number 2, and we have alpha is equal to 12t minus 12. This is by equating 1 and 2. Now alpha is equal to 12t minus 12, also alpha is equal to 0 according to the condition given. So from here we can calculate the value of time, and the value of time comes out to be 1 second. So if we look at the options, our result goes with the option number D, time is 1 second. So the answer for the second is option D. So this is the question number 3. Three objects, a solid sphere, B, a thin circular disc, and C, a circular ring, each have same mass m and radius r. They all spin with the same angular speed omega about their own symmetry axis. The amount of work W required to bring them to rest would satisfy the relation, and the relations have been mentioned in the order of increasing or the decreasing with respect to the work done. This question has come in NEET 2018, and this is on the page number 174 of old NCRT. So let us see whatever is asked in the question is about the amount of work required. So the work required to bring these objects to rest will be half I omega square. Now this omega is a constant quantity. Since it have been mentioned, they are moving with the same angular speed. Since omega is same for three of them, therefore work done is proportional to the value of I, the moment of inertia, and the moment of inertia for a solid sphere is 2 by 5 of mr square. This I have given also the list of the moment of inertia and its value in the concepts before these questions, so you can refer them. Then moment of inertia for thin circular disc is half mr square, and moment of inertia for a circular ring, it is mr square. So WA, that is for the solid sphere, is proportional to 2 by 5 of mr square. WB is proportional to half mr square, and WC, it is proportional to mr square. Now taking a ratio of them for the comparison, we have 2 by 5 mr square is to 1 by 2 mr square is to mr square, or 2 by 5 is to 1 by 2 is to 1. So we will multiply throughout by 10, taking the LCM of the denominators. So we have, multiplying this throughout by 10, we have 4 is to 5 is to 10. So the ratio of A is to B is to C is 4 is to 5 is to 10. It means the work done by the C is the circular ring, it is more. So WC, from here we conclude WC is greater than WB is greater than WA. So this is the conclusion we have drawn from our calculation. And if we look at the options, the option number C goes with our conclusion, and the answer for the third is option C. Question number 4. Two rotating bodies A and B of masses m and 2m with the moments of inertia IA and IB, where IB is greater than IA, have equal kinetic energy of rotation. Let LA and LB be their angular momenta respectively. Then these four options have been given for the condition between the angular momenta of A body and B body. And this question has come in the NEET 2016. We have been given in this question that these two bodies have equal kinetic energy of rotation. So kinetic energy of rotation is given by half I omega square. Now we need to have the angular momenta also related in this question. To have it, multiply and divide by I. So we have half I square omega square upon I. Since the angular momentum L is equal to I omega, therefore kinetic energy is equal to L square upon 2y. So we have got the relation between the kinetic energy, angular momentum, and the moment of inertia. Since the kinetic energy of body A and B are given, they are equal. Since kinetic energy of body A is equal to kinetic energy of body B, therefore we have LA square upon 2IA, where LA is the momenta that has been given for the body A, and IA is the moment of inertia of the body A. This is equal to LB square upon 2IB for the body B. From here we have 2 cancels with 2. LA square upon LB square is equal to IA upon IB. Or we have LA upon LB is equal to root IA upon IB. Now one more thing is given to us, IB. the moment of inertia of the body B is greater than that of A, since IA is less than IB, therefore LA is less than LB. So if we look at the options, we have option number C. We have LB is, from here we have, or LA is less than LB or LB is greater than LA, one and the same thing. So we have option number C, and the answer for the fourth is option number C. LB is moment of inertia, angular momentum of body B is greater than angular momentum of body A. Now the next topic is angular momentum and its conservation. In that, the first question is, a bob is whirled in a horizontal plane by means of a string with an initial speed of omega rpm. The tension in the string is T, and if speed becomes 2 omega while keeping the same radius, the tension in the string becomes, and these four options have been given. This question has come in the NEET 2024, and it is on the page number 121 of new NCRT. So let us start this. In this numerical, there have been mentioned a bob is whirled in a horizontal plane by means of a string with an initial speed. It is omega. RPM means the rotation per minute. So we have the initial speed is omega RPM, and the tension in the string is T. If speed becomes 2 omega for, say, T dash, the speed is 2 omega, and we need the same radius is not going to change. The tension in the string becomes, here, the centripetal force of the string is equal to the tension in the string. So what is the formula for the centripetal force? It is mv square by r, and v is equal to r omega. Therefore this will become, centripetal force will become m r square omega square by r. So this will become mr omega square. Now this centripetal force is equal to the tension in the string according to this concept. So therefore T is equal to mr omega square. And for T dash, this is the tension in the string when the speed become 2 omega. So T dash will be equal to mr 2 omega whole square. Now we need to find out how the tension in the string becomes by changing it. So let us take the ratio. Mark it as equation number 1. This is equation number 2. So 2 divided by, first, this will give T dash by T is equal to mr 4 omega square divided by mr omega square. So these cancel out, and T dash is equal to 4 times the T. Means this time when the speed has become 2 omega, in that case the tension in the string becomes 4 times the initial tension. So if we look at the option, our result goes with the option number B, and the answer for the first is option B. 4 times the tension will be there in the string if the speed becomes 2 omega. See the second question. A solid sphere is rotating freely about its symmetry axis in free space. The radius of the sphere is increased, keeping its mass same. Which of the following quantities would remain constant for the sphere? And these four options have been given. This question has come in the NEET 2018 and it is on the page number 121 of new NCRT. So if we look at the options one by one, we can see which are the things that are going to remain constant and the things that will change. If the radius of the sphere is increased but mass is kept constant. So in this option A, the first one is rotational kinetic energy. So if we talk about the rotational kinetic energy, the formula is half I omega square, and I is the moment of inertia, the value is mr square. So in this case, the kinetic energy is depending on the radius and the radius is increased. So there will be definitely change in the rotational kinetic energy that won't remain constant. So option A won't be the answer for it. The next is moment of inertia that we have discussed here also. The moment of inertia is equal to I uh, is equal to mass into the square of the radius of gyration mr square. So here again, since radius is being changing, so this moment of inertia, this quantity also again won't remain the constant. Next is the angular velocity. Angular velocity denoted by omega is equal to linear velocity into the radius. Again, it is consisting of radius, so angular velocity will change on change in the radius of the sphere. So angular velocity will also won't be the option. It won't remain constant. Now we'll go to the D option, angular momentum. So if we talk about the angular momentum, this thing can be related with the torque external is change in the rate of change of angular momentum. Since there is no external force applied in this case, so external force tau external is 0. So this is the reason the L, that is the angular momentum, will be constant. The angular momentum is constant. So our option D, angular momentum. So this thing is going to remain constant if the radius of the sphere is increased but mass is kept constant. So option D is the answer for the second. Let us see the third question. A thin circular ring of mass m and radius r is rotating about its axis with a constant angular velocity omega. Two objects, each of mass m, are kept gently to the opposite ends of a diameter of the ring. The ring now rotates with angular velocity given by, and these four options have been given. This question has come in All India PMT 2010, 2009, and 1998, and it is on the page number 108 of new NCRT. So let us solve this question. You can see here that in whole of the statement, again we will recap whatever the things have been given. There is a circular ring and it is moving with velocity omega. Capital M is the mass and small m is the radius. Now what have been done? Two objects of mass small m are kept gently to the opposite ends of diameter of the ring. So in whole of this question, no external force or the change in the external force is there. So concept will start from here. Since the external force change is not here, therefore the angular momentum remains conserved. एंगुलर मोमेंटम रिमेन्स कंजर्व्ड का मीनिंग क्या है कि एंगुलर मोमेंटम जब हमारी पहले सर्कुलर रिंग रोटेट कर रही थी और जब उसके ऊपर दो ऑब्जेक्ट्स जो m मास के थे उनको अटैच कर दिया, तो दोनों ही टाइम में एंगुलर मोमेंटम में कोई चेंज नहीं आया, वो कांस्टेंट है, क्योंकि एक्सटर्नल फोर्स जो है यहाँ पर कोई भी डिपिक्ट नहीं हुआ है. सो I1 omega 1 is equal to I2 omega. This is before attaching the masses, and this is after attaching the masses. And what we have to calculate? We have to find out the velocity, angular velocity with which the ring is rotating now. Means we have to find out the value of this omega 2. So I2 omega 2 is equal to, now this I, this will be m r square. M is the mass and r is the radius. So this I, moment of inertia, will be given by mr square. And omega 1 will be taken with the velocity omega. Now the new mass after attachment I2 will be m, because two objects of each mass m have been attached, so it is 2m r square. Now r square cancels with r square, and omega 2 is equal to m omega upon m plus 2m. So this is how we have calculated the angular velocity. And if we look at the options, or option number D goes with our result. So the answer for the third is D option, m omega upon m plus 2m.